Welcome. This time we're going to talk about nested or hierarchical state diagrams. So this is an absolutely classic example. Let's say that this is the state diagram for some kind of electrical device. Let's say it's a fan. Okay. Now, most of this is fairly self-explanatory. We've got a state in which the fan is off, and then we've got a large state over here in which the fan is on, and we can move it from the off state to the on state and back via events called turn on and turn off. I haven't put any brackets around them, any brackets after them this time. I'm kind of indicating that these events are probably not the receipt of messages, because we seem to be modelling a physical device here, so they're probably some other kind of event. And UML has lots of options for that, which we won't really go into, but that's just a notice for now. But the interesting part here is that inside this on state we've got what is essentially another state diagram. So when the fan is on, it may be on and on low, or it may be on high. So we've got substates within the on state, and we can transition between these substates via these transitions up and down in the obvious way. And this is just allowing us to give us a bit more information. Notice that the transitions are going to the boundary of the superstate here. So, for example, if the turn off event happens, it doesn't matter whether the fan is on low or on high. The turn off event is going to make it jump right out of the on state and any substates that it was in and take it back to the off state. Okay, but that gives us a question as to what happens when we turn on the fan. So when we turn on the fan, it's got to end up on, but is it going to end up on and low or on and high? Well, that sounds a bit like start states, doesn't it? And I realise that I didn't put a start marker on the whole diagram. Strictly speaking, it's optional, but it's usually a good idea to have them. So let's indicate that when the fan object is initially created, or when the fan is manufactured, it starts off in the off state. We could have done something just like that in the superstate, and sometimes that's what you want to do. So we could have just had another start marker saying we're going to start it in the low state, in which case instead of this H in a circle we would just have had a solid filled in circle just like the one on the outside, and then you'd have known what that meant. You'd have said, when we reach the on state, the initial state is going to be low. The H stands for history, is doing something a little bit more subtle, and sometimes it's useful, because what it's going to say is the state into which we go is going to depend on the history of the last time we were in this state. So if we were ever in the on state before, and then we leave it and then we come back to it, then the substate we go to is going to be the same substate that we were in last time we were in the on state. So if we were on and high last time, and then the turn off event happened and we turned off, and then the turn on event happens and we come back, then, because there's a history marker here, we're going to go back to the high state. Okay. Now, the H in a circle kind of tells you that that's the situation we're in. You're going to remember what substate we were in. What does it mean that we've got the arrow from the history pseudostate to the low substate here? Well, that indicates if there isn't any history, so if this is the first time that we're in the on state, then we go to the low substate, which, if you think about it, is very useful. You need to know what's going to happen as a default if you've never been in this superstate before, and the arrow tells us that. But the fact that it's an H here rather than just a filled-in circle tells us that if we ever have been in this state before, then instead of just going to the low state, we're going to go to whatever state we were in before, whether that's low or whether it's high. And that is about all you need to know about hierarchical state diagrams.